All right, we're gonna continue the next two sections. They're pretty quick, and they pretty much have the same concepts behind them. We're gonna do graphing rational equations and then solving inequalities, rational inequalities. Note this Thursday and Friday, there's no classes because the faculty have to go to professional development. So you guys have no classes on Thursday or Friday. And next week is the last week before spring break. So time's flying pretty quick. So, and I hope you all got the progress reports to see where you're standing. It's either, if you're unsatisfactory, it means you haven't caught up just yet where we are. You're still in chapter 2, we're in chapter 4. It doesn't mean you're failing anything, you just speed up the work. And if you're satisfactory, you're close enough, you're good enough where you're supposed to be. All right. Notice also when I do the grades, I erase all of the media grades. Anything, all the videos you watch, those don't count any points. I delete those and I only count the work that you actually did. All right. So let's look at this. The first section, the first chapter, chapter 4, section 4, the graph of rational functions. Rational functions look like this. What's the only stipulation about rational equations, about fractions? What can you not have in fractions? Where? The bottom, yeah. So the bottom function cannot equal 0. Let's go for some bonus points here. What do you call the x's that make the bottom equal 0? What are those called? What are the x values that make the denominator equals 0? Called. Solutions. They said we can't. It's the opposite of solution. This, as far as you can get from it. Do 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 do. Wrong. Vertical asymptotes. Remember how you find vertical asymptotes? Take the bottom, set it equal to 0. Those are values you cannot use. The graph cannot cross those. So let's look at the procedures that we're going to solve these things. Well, let's look at the first example we have. And then I'll put the steps right here. So we have x squared minus 4, x squared plus 3x minus 4. The first thing you do, factor the numerator and the denominator. So if we were to factor these, what would the top one factor out into? We know we're supposed to have 2 answers. How do we know we're supposed to have 2 answers? Right, because the degree says 2. We have 2 answers. Same with the bottom. So let's look at this. So what makes x squared? X times x. Remember, a polynomial of degree 2 is quadratic. In standard form, they look like this. You have the squared term, the single, but ours, we're missing the middle one. So here we have a negative. If that's a negative, that means the signs have to be different. Yeah. So what times what is 4? When you add or you subtract them, you get 0, 2 and 2. This is the difference of two squares. Same on the bottom. We have x and x. In front of 4, it's a negative. Since it's negative, the signs are different. And the bigger number gets the plus sign. What times what equals 4? When you subtract them, you get 3. Yeah, so you get 4 and 1. So it's positive 4 and negative 1. Well, whenever you have opposite signs, whenever the second sign's a minus, the first sign tells you the bigger number gets that sign. Because if we added these together, we get -1 plus 4, when you get a positive 3. Okay, now why did we factor those out? When the numerator equals 0, what does that find for us? What'd you say, second one? X-intercepts, yeah. But you can call those solutions. Because to find a solution, you set the function equal to 0. We're looking for where line crosses the x-axis. So the only way you can find the x-intercepts is by setting the top equal 0. Or in order to get rid of the bottom. You don't need it anymore. When the denominator is set it equals 0, what does that find for us? The vertical asymptotes. So what we found here, we found the vertical asymptotes. We found the x-intercepts. The second thing, find the horizontal asymptote. So in this example, what is our horizontal asymptote? It's 1. Because all you do is look at the leading terms. If they have the same exponents, it's their coefficient. So 1 divided by 1 is 1. So we know we have a horizontal asymptote here. Where are our vertical asymptotes? -4 and +1. So we found our horizontal and vertical asymptotes. Now find our x-intercepts. Right, set both of these equal to 0. So we got -2 and +2. How do we find the y-intercept? Set x equals 0. So if we set x equals 0, what do we get? -4 over -4 is +1. So we have the basic shape of the graph. We know where the compartments are. Then you plot some points in each interval. So let's pick some points. We cannot use -4. We cannot use +1. Well, we know what happens at 2, a -2 and 2. Those are intercepts. So we cannot use this and we cannot use this. Plot some points on this side between these and these and see where it lays. So at -5 and at -6, let's look at what happens to those. I like to use, for this part, I like to use the factored part. Makes it much easier. Because -5 plus 2 is what? -3. -5 minus 2 is -5 plus 4. -5 minus 1. So we have 4 negatives. The answer is going to be positive. The 3 and the 6 cancel. So we have 7 over 2, which is 3.5. So at -5 is going to be 3.5. 1, 2, 3.5. Put that there. At -6. -6 plus 2 is -4. -8. -2. -7. Answer is going to be positive. 2 and the 4. So it's 16 over 7. 2 and 2/7. So what do we notice about our points going to the left? They're going down. So we know that this part's going to look like this. So that's in this first interval. Now in this middle one, we can't use -4 or 1 because those are our vertical asymptotes. We know at -2 it's 0. We know at 0 it's 1. So we plot the other points. -3 and -1. -3 plus 2 is -1. -3 minus 2 is -5. -3 plus 4 is 1. -3 minus 1 is -4. The answers are going to be negative 5/4. And at -1, we'll have 1, -3, 3, -2. Negatives cancel. The answer is 1/2. So in this middle segment, our graph will look something like this. It has that shape. And the last segment we have from 2, 3, and 4. We have at 2, it's 0. So we'll look at 3 and 4. Again, I'm using the factored form to plot my points. So 3 plus 2 is 5. 3 minus 2 is 1. 3 plus 4 is 7. 3 minus 1 is 2. 5/14, which is pretty low. At 4, we get 6, 2, 8, 3. So 2 and the 8 cancel. It's 1/2. So on this side, it's going to look something like this. So there's our graph. We know it can't cross that, the vertical asymptotes. And since it approaches this horizontal asymptote, the only place it crosses is here. So just piece together parts of the graph. Let's try another one. Let's look at example 1. I'm going to let you guys graph this one before I do anything. Some of this stuff. The top is already factored out. What does the bottom factor out into? Plus 2, x minus 2. So what is, we have to find the X-intercept, the Y-intercept, the horizontal asymptote, and any vertical asymptote. So what's the X-intercept or X-intercepts? 1. It's where the top set equals 0. So x minus 1 equals 0, so x equals 1. What's the y-intercept? Hmm? 1/4. If we set all the x's equal to 0, we got -1, 2 times -2. So it's -1 over -4 is 1/4. Horizontal asymptote? Is 0 because there's more x's on the bottom. So it's 0, which means it's the x-axis. The horizontal asymptote is the y value. It's a horizontal line through y. Vertical asymptotes. Right. All right. So we have our vertical asymptotes at -2 and +2. We have an X-intercept at 1, a Y-intercept at 1/4, and the horizontal asymptote is there. So we have to look at values here, here, and here. So let's look in the first one. At -3 and -4. -3 minus 1 is -4. -3 plus 2 is -1. -3 minus 2 is -5. The answer is going to be negative. There's 3 negatives. 4/5. At -4, we got -5, -2, -6. The answer is going to be -5/12. So what do you think happens in this quadrant? Yeah, it'll be close to the horizontal to the asymptote. And then it go back down this way. So that's how that one's going to look. We know it doesn't cross the x-axis because there's no x-intercepts there. So it won't cross that horizontal asymptote. How about in this one on this side? At 3 and 4. 3 minus 1 is 2. 3 plus 2 is 5. 3 minus 2 is 1. So we got 2/5. Four minus 1 is 3. 6, 2. So that's 1/4. Same thing here. Now the question is what happens in the middle? We know at 1 it's a 0. At 0 it's a quarter, 1/4. What happens at -1? We got -2, 1, -3. That's positive 2/3. So. Look like this. What do you think so far? Pretty straightforward. All right, let's look at example 2. Graph that function. All right, so to find the x-intercepts, we set the top equal to 0. So x squared minus 1 equals 0. X squared equals 1, which equals plus or minus 1. Because also we could factor that out. We get x plus 1, x minus 1 over x. The y-intercept. Do we have a y-intercept? No. Why is there no y-intercept? Goes to 0. Very good. To find the y-intercept, set all the x's equal to 0. It doesn't work. So we have no y-intercept. Do we have vertical asymptote? Vertical asymptote is where the bottom equals 0. It's the y-axis. Do we have a horizontal asymptote? No, because the top is bigger than the bottom, but it's bigger than the bottom by 1. So what does that mean we have? An oblique asymptote. So to find the oblique asymptote, we do long division. Remember, oblique asymptotes is if the top exponent is bigger than the bottom by 1. What times x gives me x squared? X. Change signs. So that's all we have. It doesn't fit in there. So we know our graph, the oblique asymptote, will look like this. So what do we do now? Our x-intercepts are at 1 and -1. Our vertical asymptote is the y-axis. So what's our graph going to look like? Let's plot some points. We have these points and these points. So try -2, -3. Likewise, on this side, we'll try 2 and 3. If we need more, we'll try them. I'm going to use the factored form. So at -2, we got -1 minus, so it's -1, -3 over -2. The answers are going to be -3/2. At -3, we'll have -2, -4, -3. So it'll be -8/3. So it's going to look like this. And since this is a horizontal asymptote, a vertical asymptote, our other side is going to look similar to that. So there's our graph. Only one vertical asymptote. What do y'all think? It's the same repetitive steps. Find the horizontal asymptote, vertical asymptote, X-intercepts, Y-intercept, and plot some points. All right, let's look at example 3. This one's going to be interesting. Let's first answer these 4 questions here. X-intercepts. None? How do we find the X-intercepts? Okay, so let's set x to the 4th plus 1 equals 0. Won't have any because it's an even root, cannot equal negative. So none. Because if we take the 4th root of both sides, we have an imaginary term, which tells us that our graph is going to be off the x-axis. It'll either be above or below, but since it's all positive, it'll be going up. We have a y-intercept. To find the y-intercept, set all the x's to 0. We got a 0 on the bottom, so no y-intercept. Do we have a horizontal asymptote? No, because there's 4 on the top, 2 on the bottom, so it's x squared. So if we divide it by x squared, it goes to infinity. How about vertical asymptote? Finally, we got something. A bunch of nothings. So we said this is our vertical asymptote. We have no x-intercepts. We have no y-intercepts. So what do we do next? Plot points. Let's plot some points to the left here and to the right. So at -1, we'll do -1, -2, -3. And then same thing on this side, be +1, +2. So when x is -1, we have 1 plus 1 over 1, which is 2. Same thing, because it's an even function. When x is 2, or -2, we got 16 plus 1 over 4. We got 4 and 1/4. So the farther we go down, we'll do the same thing. So what happens at 1/2 or negative 1/2? So we have 1/2 to the 4th plus 1/2 squared. 1/16 plus 16/16, 1/4. 17/16 is 7. Same thing, it's 4 1/4. So we know we have our graph has to be within this domain. So our graph will look like this. It has to stay within, if we just did division, we get x squared plus 1/x squared. As x goes to infinity, that one disappears, and all we have left is x squared. So this is what we have left. That's our graph. That was not an easy one, but that's how we figured out. We know we had no intercepts, no horizontal asymptote. We simply had a vertical asymptote. No intercepts. So we just plot some points. At -1 and 1, those were the lowest. Everything else after that went higher and higher and higher. And it had to go up in a parabolic type shape. And if you didn't see it, you plot some more points, you'll see that the farther you go away, and -3, -4, -5, the higher it'll go. And the closer you get to the asymptote, the bigger it gets as well, because you reciprocate the function as it becomes much larger. Yeah, it's just that one, it's just the plotting the points that takes the most time there. Example 4. Three x squared minus 3x over x squared plus x minus 12. So if we find all of these, we'll be in good shape. Okay. Now, if you've answered a question earlier, you cannot answer any of these questions. I want everybody else who has not participated to participate. How can we factor the top out? When we have two terms, how do we factor it? Do they have anything in common? They have a 3 and an x. Take out a 3 and 1x, I got an x minus 1. The bottom one, since it's a negative, that means the signs are different. And the bigger number gets the plus. So what times what is 12? When you subtract them, you get 1. 4 and 3, yeah. So the positive gets the 4. Did you get the sheets back there? The sheets, the last two sheets of yours. I was wondering how I had extras. Okay, so this is our factored form. So set the top equal to 0. That'll give me my x-intercepts. So I got 3x equals 0 and x minus 1 equals 0. So 0 and 1. What are my y-intercepts? Or intercept. How do you find the y-intercept? Yeah, so there's all these x's, just cancel them out. So we got 0 over negative 12, which is 0. Horizontal asymptote. Do we have a horizontal or oblique asymptote? 50-50, yes. What is a horizontal asymptote? Look at the original equation.
0. Wait.
Because the leading terms are the same exponents, it's just the coefficients.
Oh, I'll do the factor one.
No, not for the horizontals. Yeah, let's look at that. What's my vertical asymptote? Yes, I take the bottom, set them equal to 0. So I got x plus 4 equals 0, x minus 3 equals 0. So x equals negative 4 and x equals 3. So my x-intercepts are at 0 and 1. Y-intercept is at 0. Horizontal asymptote is at 3. Vertical is at negative 4 and 3. Any questions about what we do there, how we got those that much? Because that gives us our template of what a graph's supposed to look like. And this one here is pretty interesting because we have a y-intercept at 0, x-intercept at 1. So we have two intercepts there. So now we plot some points from this interval, and from that interval. So at negative 5 and negative 6. So negative 5 times 3 is negative 15. Negative 5 minus 1 is negative 6. Negative 5 plus 4 is negative 1. And negative 8. So it's going to be positive 15 times 3 is 45 over 4, which is 11 and 1/4. That's all the way up there. So I'm going to take a wild stab at this one. It's going to look like this. Because, yeah, the outer quadrant is going to have that shape because it's not going to cross the horizontal asymptote. And since there's no x-intercepts, it has to be there. Likewise over here, there aren't any x-intercepts. So where's my graph going to be? Above or below the horizontal asymptote? Has to be above. So the only question I have now is in between here. Yeah, -1, -2. I might as well look at each one of those. And also at 2. So negative, that's -3 -2, 3 -4. So the answer is going to be negative since there's 3 negatives. 3's cancel. It's 1/2. So -1/2 at -1. At -2, I got a -6, -3, 2, -7. So it should be -9/7, which is -1 2/7. Okay, so this side's going to go down. What's happening at 2? 2 times 3 is 6. 2 minus 1 is 1. 6, -1. 6 cancels, so we get -1. There's our graph. Knowing the X and Y intercepts, we know pretty much once the points start being below the X axis here, it's got to approach the asymptote. Once it's below the X axis here, it's got to be approaching the asymptote. I know those. Same thing here. As X goes to infinity or negative infinity, the values will get small. As X goes to the limit points, it gets taller. Let's do 40 more. Example 5. R of X. This is with a hole. Okay, my question is here, how do we define a hole? How do we get a hole in on our graph? Holes occur when we have a removable discontinuity. In other words, what that means is when we factor it out, something from top and bottom cancel out. The same factors cancel out. Those that at that point, even though it's a vertical asymptote, there's a hole. And that's where the graph can cross through that hole. Does anybody have trouble factoring the top type of equation? I'll show you the way I do it. It's much easier. All right, so let me factor the top. In other words, whenever you have a leading coefficient as A, if A is not equal to 1, whatever term you have here, put that in both spaces. Don't waste any time trying to figure out where it's supposed to go. That's your first step. Second, look at the second sign. If it's a plus, that means both signs have to be the same. They have to be the first sign. If it's a minus, then they're opposite signs. The bigger number gets the first sign. Now, take the first term and the last term and multiply those together. So we have 2 times 2, gives us 4. Now we got to figure out what times what equals 4. When we add them, we get 5. No, 4, just use 4 right now. We won't worry about the signs anytime soon. So we have 4 times 1 is 4, 4 plus 1 is 5. So those numbers go inside here. So far, so good. Now, look inside these parentheses. Can anything factor out of each of these parentheses? A 2 can factor out of the first one, leaving with x minus 2, and nothing out of the second one. Whatever you factor out, delete it, erase it. That's our factored form right there. It always works. So we got x minus 2, 2x minus 1. And the bottom's the difference of 2 squares. Yes.
Second parentheses. Why isn't it X minus 1?
On this one,
Yeah.
because I can't factor anything out. This,
Oh, well,
yeah, so, and that's what I'm saying, because what if we had something like 14 right here? We won't try to figure out the different combinations of 14, but we said, just put it 14 and 14 here, figure the rest of it at the very end. Whatever you factor out, whatever you're left with inside the parentheses is your factored form. So this method always works. So do we have vertical asymptotes? Two and negative 2. Yeah, let's take it from there. I'll get to that. You have to look at the original function. But now, remember, we'll have a hole because we can cancel it out through that vertical asymptote. We first have to notice what intercepts asymptotes do we have. Even though the x minus 2s are going to cancel, we have to take consideration that our intercepts are going to be 2 and negative 2. Not intercepts, but the points of contention. Do we have a horizontal asymptote? Where's that? At 2. because the exponents are the same, the degrees are the same. So just the coefficient. What's the y-intercept? -1/2. Very good. Because all the x's are gone, we have 2 over -4, which is -1/2. X-intercepts. Two and 1/2. So let's look what this means so far. At -2, we have an asymptote. At 2, because these cancel, that's a removable discontinuity. At the value 2, if we plug that back in the equation, at this one here, what we have left we get 3 over 4. So at 2 3/4, we have a whole. Because that's where the other asymptote would have been. But the graph can cross that point. Except can't cross it, it's gonna skip over that point. And we have a horizontal asymptote at 2. The x-intercept is at 2 and 1/2. It can't be at 2 because it'll make it undefined. So plot some points. We're going to be using our modified. So at -1, we'll see what that looks like. At -3 and -4. I'm thinking that on this side of the asymptote will be up here, and this one's going to be down here. That's just by looking at these points. So at -1, we have -2 minus 1 is -3 over 1 is -3. At -3, we put that in there, we get -6, that's -7 over -1, which is 7. Seven. So yeah, this side's gonna look like this. And this side's already. So our graph looks something like that. And how many of y'all have heard of Desmos? Ever used it? So yeah, work the stuff out and then check your answers using that. Use technology to supplement your learning. I mean, to check your answers, not to replace your learning. And we have time for one more question. That's looking at example 6. It says constructing a rational function from its graph. In other words, we want to construct a rational function from this graph. We have 2 vertical asymptotes. Where do vertical asymptotes appear on your function? Top or bottom? Bottom. Don't go to Vegas. So, so remember, it's the vertical asymptotes are where the bottom equals 0. So if x equals -5, what's the equation that satisfies this line? Yeah, so x equals -5, add 5 to both sides. We get x plus 5 equals 0. X equals 2. Very good. X minus 2 equals 0. So that takes care of the bottom part, the horizontal, the vertical asymptotes. We have an x-intercept at -2 and at 5. Where do we find the x-intercepts? Above or below the top or bottom? Top. So we have, for if x equals -2, that means x plus 2 is equal to 0. And if x equals 5, that means x minus 5 is equal to 0. So far, so good. We've gotten the vertical asymptotes. We've gotten the intercepts. How do we figure out the horizontal asymptote? How do we get the horizontal asymptote to equal 2? The degrees have to be what to have a horizontal asymptote of 2? Has to be the same. Well, this is x times x is x squared, x of x, so x and x squared. So that means a horizontal asymptote has to have just the coefficients, which are 2/1. That means we have to have a 2 and there's a 1 down there. So those are our equations. That's how we constructed the rational function. We could multiply these out, of course, and that'll give us a better picture. But that could work. In other words, we have 2, this would be x squared minus 3x minus 10, x squared plus 3x minus 10. And then we can distribute that. I don't know how the computer wants the answer. If it was just me, I'd be fat, dumb, and happy with this. Because that way, you can tell me, you can look at it, you can tell me where these x-intercepts and the vertical asymptotes are. If it was squared, then would the degrees be the same? I know the concept is if it bounces, it has to be an even exponent. But if we had at this one, if it was squared, then we'd have a 1, a 1. We'd have degree 2 over degree 3, which would make it our horizontal asymptote would be the x-axis. So there's the difficult part there. Because for our vertical asymptotes,
they go down at the same place, it's not down, one is down. Not one coming from negative infinity and one. One coming from negative infinity and one coming from positive. When I think we have to hit that aspect, that asymptote.
is it at -5?
Figure out that x is going down towards that vertical asymptote. I think that's where another square is. I think it's a cube on the top and a cube on the bottom. Yeah, where you have, see where you put a square at x minus 2, that'd be right. And you have a square at x plus 2 at the top, that would be right. And then it's a cube.
Well, yeah, because you're right, that could work. But yeah, the concept is here's this. Whenever you graph polynomials, if you have a multiplicity that's even, the graph bounces off the x-axis there. If you have a multiplicity that's odd, the graph crosses that point. So at -5, at 5, this one has, since it crosses, it has to have a multiplicity of odd. That means if we're gonna have, that means this one could have 2 of them, this one could have 2 because it bounces off that. Yes. Unfortunately, we don't have time to do the next section, which is pretty short. But those are inequalities. We'll do that next time. There's no school Thursday or Friday. And spring break after next week. So I'm gonna try to finish up this chapter by the end of next week, which we should, because we have 2 more sections. And I'm gonna spend the day just doing example problems of the entire chapter. All right, everybody, have a great, safe day. Enjoy the sun.